Alright, hey guys, so today we're going to go through and accomplish getting some significant figures practice. Now we're going to focus on first identifying the number sig figs, then we're going to do some basic addition, and then we'll conclude it with some multiplication. And so I'll try to make sure that I don't make any mistakes. I may need a calculator later, as it proves a little bit easier to have a calculator on your person. So without any further ado, let's get started. Alright, so any first, I want to start off with the first rule that I usually start off with when we talk about sig figs. And that's basically that numbers falling between 1 and 9 are significant. So if you look at this first example, all of these numbers are significant. And so you start off with a 5 for number sig figs. Moving on to the right, anytime a 0 is sandwiched between two non-zero digit numbers, they are indeed going to be significant. Therefore, makes this grand total of 4 sig figs present here. Now, moving to the right, if you look closely, there are no decimal points. That means these zeros are actually ambiguous, and therefore, because they're ambiguous, we don't really know the role they fill. Now, they're there, but they don't have any significant value. And so, consequently, you end up with a significant figure number of there being only 1, and that's the 7 present. Now, if we look here at 107.854, the 0 here is actually sandwiched between two non-zero digit numbers. It's found between a 1 and a 7. And so in that case, that 0 is significant, and the other numbers obviously are significant, so you end up with a grand total of 6 significant figures. Now let's look at this number here. Here you notice there are zeros found on the left and zeros found on the right. Now, there's a rule that says zeros found on the right are significant if there's a decimal point. Now, there's a decimal point, and I don't want you to get confused because the zeros on the left are indeed not significant, but the one on the right is, only because of that decimal point. So we end up with a grand total of 3 significant figures for that number. Now, looking onward, if we look at this 350, the zeros are actually, one of the zeros is sandwiched between the 5 and the 6. That makes this 0 significant. Now the 0 to the right of that 7 is actually significant only because of this little guy here, a decimal point. And it's important. So when you add up all these, you end up with a grand total of 6 significant figures. Now moving on, I don't know if you can see that, but that number is 100.3. And in that case, because there is a decimal point there, and that number is sandwiched between two non-zero digit numbers, those zeros are indeed significant. So that makes it a grand total of 4 significant figures. Remember, I'm focusing on the rules of zeros because any number that's not a 0 automatically is a significant number no matter where it's placed. So here we're looking again at this 1, 4 and this 0.60. Yes, that is a decimal point. So that makes these two zeros of significance. Therefore, we have a grand total of 5 significant figures. Now looking at the next one, that number actually says 1.0000. And so those 4 zeros are significant, and that contributes to there being a grand total of 5 significant figures. Let's look at the next one. You have 0.678. That 0 is there. However, it's found to the left of the non-zero digit numbers. Therefore, it is not significant even with a decimal point. And therefore, you have 3 significant figures. Moving on, looking at this here, you have 0001. Again, we have the same scenario where we have a decimal point, but those zeros are found on the left-hand side. And so, consequently, the only significant value is that 1. And so, there is 1 significant figure. Now let's look at this last one. There are 3 zeros. All 3 of these zeros are found between a non-zero digit number. And so you don't need to know about a decimal point. You just need to know that they're sandwiched between 2 non-zero digit numbers. And that makes them significant. You pile that in with the 3, 2, and the 1, and you end up with a grand total of 6 significant figures. Now let's look at this addition and subtraction. Bear with me a little bit here. I'm not as great at addition and subtraction looking up over the top. So kind of going through slowly here. I have one rule about addition and subtraction, and I need you to compartmentalize that. Make sure you focus on that versus just looking at multiplication and division. Now with addition and subtraction, your answer basically is not dictated by the total number of sig figs, but basically the placement of having the least number of numbers on the right-hand side. So if you look on this side of the decimal point, the 5, 6, and 7 have 3 places to the right of the decimal point. This guy right here has 4 numbers to the right of the decimal point, and this one has 1. And so when we represent our answer is going to basically, our final answer should start right there and go left. And so we'll go ahead and just do basic addition to add these guys up. And I'm using a calculator because last time I tried to actually do this, I made kind of a slight error that I did not take note of. And so I'm hoping to minimize those chances by taking this approach. And so I end up with my raw answer. Now this is the raw answer, 169.8237. However, even though this is the raw answer, my answer is going to have to be cut off based on that placeholder. So right here. So in this case, the answer will be 169.0 for this guy. Alright, so we'll look at the next one. You have 246.24 added to 238.278 plus 98.3. And so you end up with a grand total of 582.818. Let's look at this. This is 1 here, there's 3 here, there's 2 here. My answer has to stop right there at that, right after that 8. So I'm going to put it right here as my final answer. This is my final answer. Now, interestingly enough, I want to remind you that the number of sig figs rules, the number of significant figures has no basis on this answer. Because if you notice, this has 5, this has 6, this has 3, and our answer has 4 sig figs. But it's really dictated by the smallest number of significant value figures on the right-hand side of that decimal point. So let's look at the last one, and that'll culminate our addition. We're going to add 658 plus 23.5478 plus 1345.29. Our raw number is 2026.8378. We're going to have to adjust because that 0 there is the smallest one on the right-hand side, this guy. And so our answer ends up being 2026.8. And that's our answer. And let me go ahead and show you there for visual clarity. Alright, now we're going to look at some multiplication and division. The rules for multiplication and division are a little bit different. You have to understand that part of what dictates multiplication and division is the number of sig figs. And so we're going to, as we're going through, we'll first focus on the number of sig figs in the numbers, and then we multiply, we'll use that to dictate the number of sig figs our product has. So let's look at this first one. This has 3 sig figs, this has 2. Knowing that, our answer can't be more accurate than the number featuring 2 sig figs. So when I multiply 23.7 by 3.8, I'm getting 90.06, but I need to go ahead and represent that using 2 significant figures. And there's 2 ways, really. There's 90 and a decimal point, making that 0 significant. And then there's scientific notation, which can be expressed using 9.0 times 10 to the first. Excuse me. Moving on, letter B features 45.76, that's 4 sig figs, and 0.25 has 2 sig figs. So 45.76 times 0.25 yields this answer of 11.44, but we can only represent that using 2 sig figs, and so we just round it to 11. Moving on, 81.04 times 0.010 yields 0.8104. Our number of sig figs here, we have 4 there, we have 2 here. Our answer can have no more than 2 sig figs. Therefore, the answer will be 0.81. Alright, moving on, we have 3 sigs here, 3 sigs here. Our answer is going to have 3 sigs. So 6.47 times 64.5 yields 417.315, but our answer has to have 3, so we're going to make that 417. Alright, and let's switch gears here. 43.678 times 64.1. This guy has 5, this guy has 3. Let's multiply them out and see what answer we get. times 64.1. Alright, so this number obviously is 2,799.7598. We have to have 3 sig figs. That's going to be amazing because we can't write that in standard form. What we're going to have to do is adjust and actually represent this answer using scientific notation because that is really the only way of expressing it. So I get 2.80 times 10 to the first power. Actually, it's not first power. I'm sorry. It's third power. I don't know why I got first power. Anyway, the 0 has a significant value because of the decimal point, the 8 and the 2, and if you express that in standard form, you get some number that looks like 2,800. So, 2,800 rather. Alright, let's move on. 1.678, and we're going to divide that here by 0.42. Now, the rules still are the same. Your answer can have no more sig figs than the number of sig figs used to calculate the answer. And when I solve that, I end up with 3.995, blah, blah, blah. The answer has to have 2 sig figs, guys. So I'm going to express it by rounding it to 4.0. That 0 is indeed significant. Alright, next we're going to go on and look at 28.367. We're going to divide that by 3.74. We end up with this number, but because this is 5 and this is 3, our answer has to have 3 sig figs. Therefore, our answer will be represented as 7.58, and that's that answer. And then our last one, we have actually 4 sig figs there and 4 sig figs there. Our answer will have to have no more, no less than 4 sig figs. So 4278 divided by 1.006 ends up with this large number, but again, we have to have 4 sig figs. 4252. Now, one interesting tidbit that I came up to mind when I was doing the calculations is suppose that our answer came up to being a raw answer of like 1.0 or 4, actually, let's, 4.0. Let's say 4.0 was our raw answer, but our answer has to be represent 3 sig figs. Now, this is 2 sig figs, but if we have to represent it as 3 sig figs, all you have to do is add another 0 there. And I thought that was an interesting tidbit worth sharing. And so that concludes today's lesson on scientific, actually not really scientific notation, but expressing numbers using significant figures and